In this problem, it's best to just have these answers right next to it. So that's what I did here. And we can just compare. To be honest, we probably can get away without having to read that lengthy paragraph here. This is similar to the ACT science section, where you can typically get away by just knowing what the question is, which is which of the following statement correctly compares the average rates at which the temperatures of the two samples change. So how do these two graphs compare? Well, let's look at A. Every 10-minute interval, the magnitude of the rate of change of temperatures of the insulated sample, that's our insulated is going to be our gray cubes here. Okay. The magnitude of the rate of change of the insulated sample is greater than that of the non-insulated, where the rate of change is greater. Well, in this case, we can see that there's times where that's, and the keyword here is every, and what we can see here is that at a certain point, it's actually changing less, because we can see that the black dot, the non-insulated here, is actually dropping at a quicker rate at this moment. And then over here, it actually ends up changing more than the way that the black dot is changing. So what we can see is it goes in and out, it's fluctuating. So it can't be A. Every 10-minute interval, the magnitude of the rate of change of temperature of the non-insulated sample is greater than that. You see, there's that every again. So that is going to be canceled out, because we see here that in order for this black dot to all of a sudden drop here, where this one is still above it, means that this one dropped faster, the non-insulated dropped faster. Whereas here, the only way they can get closer to each other is if the non-insulated kind of just hangs out for a bit, while the insulated is still changing at a significant enough rate that it gets closer. Okay, so that's not going to be the case. In the intervals from 0 to 10 and from 10 to 20 minutes, the rate of change of the temperature of the insulated sample are of greater magnitude. So what they're saying is that the insulated changes more from 10 to 20 minutes. And that's not the case, because as we saw, it's the non-insulated that's changing more. That's why it's pulling down further down compared to the insulated squares, which are still just kind of hovering a little bit below the next one. It's a significant drop. And that leaves us with D, where we can see that in 10 to 20 minutes, the rates of change of the non-insulated sample are of greater magnitude. The black dots are changing at a greater magnitude. That's D.